variable. Now we're kind of moving into a world of two variable data sets, right? So there's different ways to represent two variables. One would be a qualitative approach, and another would be a quantitative approach. Right, so we'll start with qualitative. That's where you get into something called a contingency table, or also known as a two-way frequency table. All right. So what this does is it accounts for two variables, and with those two variables, it gives us a sense of what's going on, what the distribution of data are within those two variables. Okay, so high school students in the United States were invited to complete an online survey in 2010. More than 1,000 students responded to this survey that included a question about a student's most favorite superhero power. 450 of the completed surveys were randomly selected. Complete the table below by determining a frequency count for each cell based on the summarized data. All right, so really this is just totaling it out. Nothing too crazy. It's generally what you do after you total everything up that makes things a little bit more complicated. All right. So some of them you shouldn't need a calculator for, but some of them maybe you do. I don't know. You start getting into some funkier values, then maybe you want to use a calculator. So the first one, 100. Then we're looking at 131. 75. 26. 118. Right. Now across the row, it's a little bit more challenging. So if you're going to use a calculator, it's probably for that one. What do you say, 228? 228 and 322?
No. But we can't trust it. I use my calculator.
Well, say them again.
Don't do that anyway.
228 and 322? 222. All right, so the way to verify that at least you're on the right track is to add up your totals. All right, so 440 plus 10 gives us 450. All right, across the bottom row, you know, not quite as simple, but still doable. Right? So just verify that these add up to 450, and at least you know that you're on the right track. Not a guarantee, because sometimes you can make offsetting mistakes that somehow end up giving you the right sum, but the likelihood that you made a mistake is very small. All right. Shaded cells are called the marginal frequencies. All right. So that's kind of an easy thing to visualize, I suppose. Because if you're talking about a piece of paper, you know, you're taking notes in a notebook, and I said to write something in the margins, you'd probably know that I was talking about on the side. All right, so we're talking about side values here. So when we took the sum of these inner quantities, what we were developing here are marginal values. All right, so but they're frequencies, because frequencies are counts, right, that fall within a category. So what we determined here is a few things. We determined the total number of freshmen that were polled, the total number of sophomores that were polled. We determined the total number of students in general that want or preferred or had a favorite superhero power of flying, of freezing time, and so on. All right, so we got a lot of valuable information out of that. Those are the marginal frequencies. All right, the joint frequencies are the values, the non-shaded values that are within the table. All right, so each individual count. Right, what those end up giving us are the intersection between two variables. Right, so an example, for instance, when we're dealing with the joint frequency, would be how many freshmen preferred telepathy. If that were the question, you would look right to the intersection between those two variables. All right, so the row for freshmen and the column for telepathy. Right. So I think it's pretty easy to see that your ability to get questions right related to this topic have everything to do with knowing what the terms mean. All right. So if you know that marginal means that you're talking about the values in the margins, then you're not going to have a problem with that. If you're talking about the joint frequencies, that's a little bit more challenging to kind of reconcile with, because marginal frequencies kind of, you know, it's a term that sort of defines itself. Joint, I don't know, not so much. But if you kind of think of it as adjoining the two variables, all right? So where the two variables join with one another, like for example, sophomores and freezing times. Freezing time, I mean, who freezes time?
I would choose yeah.
No, I'm just trying to think of which superhero freezes time. I know that some of them can reverse time, but to actually, I mean, flash time is like slowing down time to imperceptible. So it's still moving forward, but it's not completely frozen. But it's going so slow that it seems like it's frozen. But I'm trying to think who actually can freeze time. Jackson will know. I'll ask him later. I'll get back to you tomorrow.
Dude, this is when you're 10 people.
All right, so these questions are pretty easy now, because if you look at them, they're not asking you to determine what the marginal values are joint. They're not using the vocabulary. It's just asking you what the most popular superpower is. So you don't need vocabulary terms to figure that out. But this is kind of getting you started on it, because questions down the line will say, determine the marginal frequency, determine the marginal marginal relative frequency, which we'll get to on the next page, joint frequencies and so on. Right? But very obvious, what is the most popular superpower? Freezing time, apparently.
That would be the least. Our man.
So, our man. From the
Who answers? I don't know.
Justice Society of America? Is that
Is that like a knockoff?
Does it say the affiliation? It's like an offshoot of it. I think Our Man is one of them. Yeah? He was in Legends of Tomorrow. Straight up murdered by Reverse Flash. Least popular?
Super strength.
Super strength. All right. So obviously these individuals do not know anything about superhero powers.
Yeah, but like you're super strong. You're not, your bones aren't. Does that mean your bones are super strong as well?
Yeah, kind of like I forget his name, but from Unbreakable, the M. Night Shyamalan movie, the new movie Glass pits the really fragile guy against the multiple personality guy from Split, and the unbreakable guy whose bones are so dense that he can't be broken.
That's
So
actually a thing. People with really dense bones.
Oh yeah.
They also have
it's
lower
like
sense.
It's like in our lab that we did.
bone density. Yeah.
I don't even know.
They
but,
kind
like,
of swim. They're just kind of sink.
All right. How many more freshmen than sophomores indicated their favorite power was telepathy? So there, we're just looking for a difference, right?
Not great.
How many more freshmen than sophomores? We just subtract the 70 and the 48.
32?
How many more sophomores than freshmen indicated their favorite power was to fly? 2. 51 minus 49 is 2. All right, so not bad. But before we move on, we want to actually kind of consider what it is we're looking at here. Because again, you got to know the terms. The first two problems are both dealing with marginal frequencies. All right. The values after that are dealing with joint frequencies. Now the fact that we're actually subtracting and adding, or in this case both cases subtracting the joint frequencies, that doesn't matter. The numbers themselves are joint values. All right. So knowing what they're called is an important part of this, and so you're going to want to take some time and make sure you study those terms. All right. On the we deal with relative frequencies. All right. Determining the number in each cell of a frequency table presents the first step in organizing bivariate categorical data. That's a fancy term, bivariate categorical data. So the bivariate part, variate is a variation on variable, the bi part meaning 2. So 2 variable, categorical, meaning that we're dealing with qualitative data rather than quantitative data. Right? So not values that we're measuring, just simply counts. All right. Another way of analyzing the data in the table is to calculate the relative frequency for each cell. Relative frequencies relate each frequency count to the total number of observations. All right. So, well, for each cell in the table, the relative frequency of a cell is found by dividing the frequency of that cell by the total number of responses. Right. So if I were you, I would underline that little ingredient right there, total number of responses. All right, can somebody just read off to me the numbers that we came up? It's the same. 100, 131, 75, 118, and then we had 228 and 222. All right, so it turns out in this case we didn't actually necessarily need all of these values, but we figured them out, so we might as well take them. So what you're doing when we're finding the relative frequency is you're taking whatever the condition is that we're working with, in this case super strength, and dividing it by the total number of values in the set. All right, there's 450 values. All right, so what percentage chose super strength? Well, they didn't categorize it as freshmen or sophomores. They're talking about people in general. So 26 people chose super strength out of 450. All right, so nearest 1/10 of a percent is what we need there. So let me just get my calculator out. That's weird. I still haven't figured out why sometimes my calculator shows up on the big screen and sometimes it doesn't. So we're looking at about, because it said nearest 1/10 of a percent, so divide and then multiply by 100. You're talking about roughly 5.8%. All right. Percent of the students surveyed were freshmen and chose freeze time. All right, so you're getting a little bit more specific. So I'm looking for a joint value, not a marginal value. The first one was referencing a marginal value. The second one is looking for a joint value, but it's still a relative frequency. All right, so 60 out of 450. So we're looking at about 13.3%. All right, so again, we want to get to a point where we're fluent with understanding of where these values are coming from, and the terminology is really important. So this again is a marginal, and this is a joint. All right, so just to kind of add to it, in both cases we're finding a relative frequency. This is a marginal relative frequency. This is a joint relative frequency. So if a question down the line says, find the joint relative frequency, you're like, oh, geez, what on earth does that mean? You know, if you know the definition, you're fine, but sometimes you could just pick it up right from the context of the problem. What percentage of the students were freshmen and chose freeze time? So you would think, the students, what are we referring to here? Well, they didn't get specific. They said the students. That would mean all of them. All right? Were freshmen and chose time, that would be the joint frequency between freshmen and freeze time. So without knowing what the term joint relative frequency means, from the context of the problem, you can pick up the correct approach to solving it. All right? Then the last thing that we're going to talk about is the conditional relative frequency. All right, this is where we kind of narrow down the playing field a little bit. It's a fraction or percentage that tells you how many members of a group have a particular characteristic. More technically, it's the ratio of the frequency in the center of the table to the frequency of the row total or column total. All right. Well, what we're talking about is a condition that's being applied. All right. So what we're doing is we're narrowing down the table based on some condition. Narrow table down based on some kind of condition, on condition. All right, so I go back to my table here. It's asking us what percent of freshmen chose invisibility. So what that's telling me is that the only people I care about are the freshmen, which is generally true. Well, by now it's by default.
Thanks, Mr. Pan.
You're very welcome. Very welcome. Now all my seniors are gone. I was looking for that. So we narrow it down. Hold on, I'm just going to pause this. Like right now, I look like I'm really aggravated, but I'm totally not. So anyway, it's of freshmen, so that's where we've narrowed it down. Now we want only the freshmen who chose invisibility. All right, so how many freshmen chose invisibility? 48. And how many freshmen are there? 228. So 48 out of 228. Multiply that bad boy by 100. We can assume this. We're still going to the nearest tenth. Well, it's not even an assumption; those are the directions. So 21.1%.
Nope, you're off. It's 20. You said 21%.
What percent of students who chose to fly are sophomores? All right. So now what we're doing is we're looking at a condition where that condition is individuals who chose to fly. So how many of those were sophomores? 51. So 51 out of 100, that's actually just equal to 51%. Because out of 100 is the definition of percent, right? Per cent. Century. Yeah. Okay. So let me just double check. I think that was it because the rest is self-guided. Yep. So your classwork/homework 28-29. Tomorrow we'll finally get into that correlation stuff.
Wellness day tomorrow.
Wednesday we'll finally get into that correlation stuff.
Wellness day.
Yeah, wellness day is a different different beast altogether. So
That's my phone.
I didn't hear that.
It's still better than coming.